Sir, you're muted, sir.
Time domain analysis is the conventional method for analyzing the network. For a simple network and with first order differential equation of a network variable, this method is very useful. But as the order of the network variable equation increases, this method of analysis becomes very tedious. For such applications, frequency domain analysis using Laplace transform is very convenient. Time domain analysis is also called as a classical method and is difficult to apply to a differential equation with excitation functions which contain the derivatives. The Laplace transform method has the following advantages. So what is the advantages is first is solution to differential equation. Solution to differential equations. Differential equations is a systematic procedure. Is a systematic procedure. Second one is initial conditions. Initial conditions are automatically incorporated. Third one is it gives the complex solution. It gives the complex solution. That is both complementary and particular solution in one step. So what is the definition of the Laplace transformation? How we are representing the Laplace transformation? The Laplace transformation of a function f of t is defined as f of s, that is equal to, we are denoting like this, Laplace of f of t that is equal to 0 to infinity f of t into e to the power of minus st into dt. The Laplace transformation of a function f of t, okay, is defined as like this. Laplace transformation that you can represent it as f of s, that is also equal to, you can represent like this, Laplace of f of t that is equal to 0 to infinity f of t into e to the power of minus st into dt. Here s is the complex variable, that is s is equal to sigma plus j omega, and the function f of t must satisfy the following condition to process a Laplace transformation. So what is the condition means, that is f of t, the function f of t 0 to infinity f of t e to the power of minus sigma t dt, this should be less than the infinity. This condition should satisfy to process a Laplace transformation. Here sigma is a real and positive. The inverse Laplace transformation is represented as Laplace inverse of this f of s, reverse process. F of s is, that is f of t is equal to 1 by 2 pi j integration of sigma minus infinity to sigma plus j infinity, sigma minus j infinity to sigma plus j infinity f of s into e to the power of st into ds. Here sigma is the real part of s. Understood? What is the definition of a Laplace transformation means? The Laplace transformation of a function f of t is defined as f of s is equal to Laplace of f of t, that is equal to 0 to infinity f of t into e to the power of minus st into dt. Here sigma s is a complex variable, that is s is equal to sigma plus j omega, and the function ft must satisfy the condition to process a Laplace transformation. That condition is, that is the function f of t, that integration of 0 to infinity e to the power of minus ft dt should be less than the infinity. And here sigma is the real and positive. The inverse Laplace transformation, Lap inverse f of s is f of t is equal to 1 by 2 pi j integration of sigma minus j infinity to the power of sigma plus j infinity f of s e to the power of st ds. And here sigma is the real part of s. This you want to copy down? Shall I dictate?
Yes, sir.
Okay, note down. Definition of a Laplace transformation heading. Definition of Laplace transformation. Under that, you note down the Laplace transform of a function. The Laplace transform of a function. See the board. F of t. F of t is defined as f of s. I'm writing in the board. F of s is equal to Laplace of f of t. Laplace of f of t, that is equal to integration of 0 to infinity f of t into e to the power of minus st into dt. 0 to infinity f of t into e to the power of minus st into dt. Where s is the complex frequency variable. Where s is the complex frequency variable, s is equal to sigma plus j omega. S is equal to sigma plus j omega. The function f of t, must satisfy the following condition. The function f of t must satisfy the following condition to process a Laplace transformation. Process a Laplace transformation, that is 0 to infinity f of t, magnitude of f of t e to the power of minus sigma t, and dt should be less than the infinity, where sigma is real and positive, where sigma is real and positive. The inverse Laplace transform, our L inverse f of s is f of s is f of t is equal to 1 by 2 pi j integration of sigma minus j infinity into sigma plus j infinity f of s into e to the power of st ds. So where sigma is the real part of s, real part of s, where sigma is the real part of s. Note down question. Calculate the Laplace transform of see the board, f of t is equal to k for t is greater than equal to 0 and it is 0 for t is less than 0 where k is constant, constant where k is constant. As we know that now here, what is the Laplace transformation formula? f of s is equal to integration of 0 to infinity f of t into e to the power of minus st into dt. So here 0 to infinity, what is the f of t? F of t is a k into remaining term e to the power of minus st into dt. Here k is a constant here. Take the k as a constant. Integration of 0 to infinity e to the power of minus st into dt. So this is k into what is the integration of e to the power of minus st? E to the power of minus st divided by minus s. That is the integration limit is 0 to infinity. This is nothing but minus k by s. Okay. Here e to the power of infinity, okay, minus e to the power of 0. E to the power of minus infinity is 0, minus into minus plus, that is value will be k by s. That is Laplace transformation of a constant is constant by s. So thus if suppose if it is a k is equal to 1, then its Laplace transformation is Laplace transform is 1 by s. Is it clear?
Yes, sir.
Next question, Noda. Copied this one.
Yes, sir.
Next question. Find out the Laplace transform of f of t. F of t is equal to e to the power of minus at, e to the power of minus at for t greater than equal to 0. F of t is equal to e to the power of minus at, e to the power of minus at for t greater than equal to 0. Find out what is the Laplace transformation of this. F of s is equal to integration of 0 to infinity f of t into e to the power of minus at into dt. So here formula e to the power of st, not at here. What is the formula? F of t into e to the power of minus st into dt. E to the power of minus st into dt. That is equal to 0 to infinity. What is the f of t? F of t is nothing but e to the power of minus at into e to the power of minus st into dt. That is equal to 0 to infinity e to the power of minus s plus a into t into dt. So that is equal to
1 by a plus yes.
yes, a e to the differential integration of is e to the power of minus s plus a into t divided by minus of s plus a. Okay, limit is 0 to infinity. So this is equal to e to the power of minus infinity divided by minus of s plus a minus e to the power of 0, okay, divided by minus s plus a. So this term is 0. It is minus into minus is plus. E to the power of 0 is 1. Therefore, this becomes 1 by s plus a. Is it clear? Just I explained how to use the Laplace transformation. I gave an example. Now we'll study properties of Laplace transformation. Now the next properties of Laplace transform. Laplace transform. First one is linearity. First one is called as a linearity. The transform of a finite sum of time function is the sum of the Laplace transform of the individual functions. Suppose f1 of s, f2 s,
Sir,
x. Ah,
can you repeat, sir?
the transform, I'll dictate, just I'll explain. The
Okay, sir.
transform of a finite sum of time functions is the sum of the Laplace transform of individual functions. That is, if f1s, f2x, etc., f1s are the Laplace transform of the time functions, f1t and f2t, etc., f1t respectively, then Laplace of f1t, f2t, etc., f1t can be represented as f1s plus f2s plus f3s. This is the statement. Note down, I will dictate linearity. Linearity. First one is linearity. The transform of a finite sum of finite, see the board, sum of SEM, sum of time functions, sum of time functions, is the sum of the SEM, sum of the Laplace transforms of the individual functions. Laplace transforms of the individual functions. Full stop. So if, note down the board, see the board. So if f1s, comma, f2s, etc., f1, fns are the Laplace transforms of the time functions of the time functions f1 of t, f1t, comma, f2t, etc., fn of t respectively. Then that is the Laplace of f1t plus f2t, etc., fn of t is equal to f1s plus f2s, etc., up to f of n, yes, f of n, yes. Proof. Consider this Laplace of, that is L of f1 of t plus f2t plus etc. f of n t. Okay. What is the Laplace of this? What is the formula? Integration of 0 to infinity e to the power of minus st into dt, no, f of t into this. What is the f of t here? What is the f
Sum
of
of
t here?
all the
All this 0 to infinity f1 t plus f2t, etc., f of n t. These are all f to t. Okay. Into e to the power of minus st into dt. This you can write it as 0 to infinity f1 of t into e to the power of minus st into dt plus 0 to infinity f2t into e to the power of minus st into dt plus integration of 0 to infinity f of nt into e to the power of minus st into dt. So this is equal to f1 of s plus f2s plus etc. f of n s. If the time functions, if the time functions are multiplied by the are multiplied by the constant then we can write like this: Laplace of a1 f1 of t plus a2 into f2 of t plus an f of n t that is equal to a1 f1 of s plus a2 f2 of s plus a of n f of n s. So here where a1 a2 and etc a3 etc an are the constants. Understood now?
Yes, sir.
Okay, shall I go to the next one? Shall I go to the next one?
Yes, sir.
Second property is a scaling theorem. Note down the second property, scaling theorem. Scaling theorem. So that is multiplication by constant k by constant k. See here, if k is a constant, then the Laplace transform of k into f of t is given as k times the Laplace transform of f of t. That is, Laplace of k into f of t is equal to k into f of s. Note down. If k is a constant, if k is a constant, if k is a constant, then the Laplace transform of k into f of t, k into f of t, k into f of t is given as k times the Laplace transform of k times the Laplace transform of f of t. F of t, that is Laplace of k into f of t is equal to k into f of s. K into f of s. Is it clear?
Yes, sir.
Okay. Now the next theorem is called as a differentiation theorem. Differentiation theorem. Differentiation theorem. F of t be a function of t and fs will be its Laplace transform. Then the Laplace transform of the first derivative of f of t can be written as Laplace of d by d f of t is equal to s into f of s minus f of 0. And f of 0 is the value of f of t at t is equal to 0. This is the theorem statement. Note down. All of you note down. Let f of t, f of t, f of t be a function of t, be a function of t, and let f of s and let f of s, capital F of s, f of s be its Laplace transform, be its Laplace transform. The Laplace transform of the first derivative, the Laplace transform of the first derivative of f of t, first derivative of f of t, small f of t is given as note down Laplace of, see the board, d by dt f of t is equal to s into f of s minus f of 0. So we here f of 0 is the value of f of t at t is equal to 0. What is the differentiation theorem means? Laplace of differentiation of f of t is equal to s into f of s minus f of 0, and here f of 0 is the value of f of t at t is equal to 0. All of you written?
Yes, sir.
Okay, next you have to proof. Write down the proof for this. Proof. Laplace of differentiation of f of t, differentiation of f of t is equal to, what is the formula? 0 to infinity e to the power of minus st ft dt no here. What is the ft dt here? Ft is here d by dt e to the d by dt f of t, d by dt f of t, d by dt f of t, f of t into e to the power of minus st into dt. This is equal to, you can write it as, this as 0 to infinity, 0 to infinity e to the power of minus st. What is the this d by dt? Dt cancel here now. What is the left out here? dft only. dft, right? Left out is d into f of t. This is have to integrate with by parts. Therefore, you can write it as put u is equal to e to the power of minus st. Okay. And dv is equal to other term, that is d into f of t. If we are confused, you can write a here square bracket d into f of t. What is the du? Differentiation of u is du is equal to e to the power of minus st into minus s into dt. Okay. What is the v? V is nothing but integration, differentiation. Integration of this is differentiation f of t is only f of t. F of t. What is the formula for now? Integration by parts now here. Integration of u into dv is equal to, what is the formula? U into integration of a v minus integration of v into
V.
differentiation of u. This is the formula now.
Yes.
You substitute this value now. Therefore, Laplace of d by dt into f of t is equal to what is the u? U is here e to the power of minus st, e to the power of minus st, and what is the v? Integration of
Into f of
v is, that is only f of t, right? V u into f of t, u into f of t, f of t. Limits is 0 to infinity to 0 to infinity minus integration of 0 to infinity minus
yes.
0 to infinity minus f of t s into e to the power of minus st into dt. Integration of f of t into differentiation of this is du, that is nothing but e to the power of minus st minus s dt. Is it clear?
Yes, sir.
Okay. What is the first term value? E to the power of minus infinity is 0. Again, minus of this.
Minus
E to
f
the,
of 0.
yes, correct. Minus f of 0. Minus f of 0. Here minus into minus, it is a plus. Plus s into integration of 0 to infinity f of t into e to the power of minus st into dt. This is nothing but minus f of 0 plus s into, what is this? F of t e to the power of minus ft.
F
This
of
is
s.
Laplace of f of t. Laplace of f of t. That is the definition, no? F of t. So therefore, this we can write it as minus f of 0. What is the, how to represent the Laplace of this? We can write s into f of s, no? Laplace of f
Yes,
of
sir.
t. That we can write it as f of s. So therefore, you can write it as Laplace of differentiation of function f of t can be written as s into f of s minus f of 0. Is it clear?
Yes, sir.
Only one student is answering, remaining. What about others?
Yes, sir, understood.
Mathematics
Yes, sir.
practice ಮಾಡ್ಕೋಬೇಕು. Copied after this?
Yes, sir.
Okay, I'll continue the same only. Note on the note. If f of 0 is equal to 0, if f of is equal to 0, then a Laplace of d by dt, Laplace of d by dt, f of t, Laplace of d by dt f of t is equal to what? S into f of s. Note down one sentence. One sentence below that. Note down. It means that differentiating a function in time domain is equivalent to multiplying its Laplace transform, multiplying its is equivalent to multiplying its Laplace transform by s. In the bracket note down, in frequency domain. So I'll repeat there once again. It means that differentiating a function in time domain is equivalent to multiplying its Laplace transform by s. In the bracket note down, in frequency domain. Next line note down. This theorem is also helpful in obtaining higher order derivatives. Higher order derivatives like second, third, etc. Second, third, etc. Now down. Let Laplace of f of t. Laplace of f of t is equal to f of s. Then we have Laplace of differentiation d by dt of f of t. F of t, that is equal to s into f of s minus f of 0. Similarly, Laplace of second derivative, that is d square by dt square into f of t. This is equal to s square f of s minus s into f of 0 minus f dash 0. So where here f dash 0 is the value of differentiation d by dt of f of t. F of t at t is equal to 0. So also for the third derivative, Laplace of d cube f of t divided by dt cube, that is equal to s cube f of s minus s square f of 0 s square f of 0 s square f of 0 minus s f dash 0 minus f double dash 0. So here f double dash 0 is the value of d square f of t, d square f of t divided by dt square at t is equal to 0. T is equal to 0.